again. So, assignment number 2, Science 3400, question number 32. I've already drawn out what's happening, but he's kicking the ball at 20.4 meters per second. He's 30.89 meters away from the goal post, which is 3.05 meters high. It is a trajectory problem. So, goes up, comes down. We do know what's happening at the apex, so that's where we're going to go. How much does the ball fall clear or fall short of clearing the crossbar? Well, that's the range. So, is the range greater or less than 38.9? Don't know. Let's figure out what the range is. Now, if the range is greater than 38.9, it could be landing underneath that 3.05, or it could be landing way out here. We don't really know. So let's figure out what exactly our range is going to be. Like the videos we saw in class today, the range is strictly dependent upon the y component. So we're going to list off what's going on in the y. My initial velocity, u, is actually equal to the y component of my initial velocity, which, I'm going to skip the trigonometry, is going to be 20.4 times sine 52.2. My initial velocity is 16.119 meters per second. I'm going to store it in memory location A. At the apex, my VF equals 0. Over here, I'm going to arbitrarily say up is positive. So my u is going to be a positive number. My VF is 0. My acceleration due to gravity is going to be minus 9.81 meters per second squared. I have a u, a VF, an A, and I'm looking for T. Dave's handbook would indicate, let's use VF y equals u, again y because we're only talking y, plus AT. Rearrange, T is going to be VF minus u all over A. VF is 0 minus u, which is 16.119 all over minus 9.81. Yay, negative, cancel. Equals to 1.6431 seconds, memory location B. So if our time was 1.643 seconds to the apex, then to find my range, or the distance, it's going to be distance width of time of 2 times our 1.6 blah blah blah, which is going to equal, which equals 3.28 seconds. That being the case, let's see what our range actually is. Our range is going to be equal to the x component of our initial velocity times our 3.28, which is memory location B, seconds, which is going to be 20.4 times cos 52.2 times 3.28, and that equals 41.09 meters. Interesting. So if we go back up here and look, it's actually going to be coming down meter in the net, but we're not sure if it's going to hit the post or above the post. So how do we figure that out? Well, let's take a look at it this way. How long, we want to see what's happening in this regime here. Well, that regime is at the 38.9 meter mark. So what's happening at this 38.9 meter mark? Well, how long did it take to get there? Let's back up at our time. Our time at 38.9 is going to be equal to our distance traveled, 38.9, divided by the x component of our velocity, because this is in the x, which is the 20.4 cos 52.2, and that equals to 3.1112 seconds. Now we need to figure out what is happening in the y at 3.112 seconds. How high up is it? Well, how high? What is high? High is distance. S equals ut plus at squared over 2. Just to recap, I'm trying to figure out how high up is the ball at this point in time at the 38.9 meter mark. Well, I have enough information now that I can solve for that distance. Now, in the past, we've always used S in the x component. We can also use it to figure out what's going on in the y component. How high off the ground is it? If I were to plug in my numbers for the total range, my distance would be 0. If I plugged in half the time of my range, it would be the height of my apex. Hint, hint. So, in this case, I'm going to use s equals ut plus at squared over 2. I ran out of room last time. Oops, what's going on here? Ran out of room last time too. At squared over t. U, we're talking y component, is my 16.119 from memory location A. Acceleration is gravity. Make sure we get our sign correct. We have a time of what? Well, my time in this case at the 38.9 is my 3.112. So let's solve for s equals, and with the magic of the pause button, I get 2.672 meters. That's how high off the ground it is. So if we go back up here and look, it's at 2.67 meters off the ground. How much does the ball clear or fall short of clearing the crossbar? Well, to answer that one, we will be 3.05 minus 2.672, which means it clears it by 0.378 meters. Now, what's second? What is the vertical velocity of the ball at the time it reaches the crossbar? Well, that time is still our 3.112 seconds. So I'm going to create another little cell, and we're looking for V final Y at 3.1112, I think it is, seconds. Alrighty, well, what equation do we want to use? Let's use V final equals U plus AT, just to keep track. It's in the Y component. So it's going to equal UY. What is my U? My 16.119 from over here, plus my acceleration due to gravity, 9.81, multiplied by my 3.112, there's another one in there, seconds. That comes up with negative 14.40 meters per second. What's the negative mean? It means it's on its way down.